at SPS, and together with my colleague Arianna Zellino of training and consultancy staff, I'm pleased to introduce you to the theme of this webinar, how to choose a statistical test. First, I want to devote a few minutes to SPS as a firm. SPS has been founded in 1994 and has been active in the world of statistical analysis and SPSS technology ever since. We are a gold business partner of IBM and a certified entity to give direct support to our customers on business. At SPS, we take care of our customers from assessing the need for analysis to choosing the most suitable statistics for data analysis solution to training on its use. We collaborate with foundation, university, research centers, companies, and so on. Today, we discuss our statistics for data analysis powered by SPSS solution as a value solution. But what does it mean, statistics for data analysis as a value solution? Why do we talk about it? Statistics for data analysis combines, along with SPSS statistical engine, our experience in the world of statistical analysis. In addition to supporting our customers directly, we sought tools that would allow us to share our knowledge. And so we added to SPSS statistics, operational tools, and value-added services. Now I give you some notes about this different item. This is Launchbox. Launchbox for us at SPS is the gateway to statistics world. This is your dashboard to keep in touch with SPS proposal for training, new features, opportunity, and so on. From Launchbox, you can activate the last 3 versions of SPSS that you have available. In this dashboard, there is a dedicated section where you could see the webinar that we have in our calendar and the direct links to register for the live event as today. Downloading the Launchbox, you have add-ons, self-installings. Add-ons are additional features built in natively, strengthening the tool, which my colleague Arianna will show you during the webinar. Add-ons are downloaded automatically when you download Launchbox. Okay, this is the information about webinar as today with the direct link to signing up. From Launchbox, there is the link to customer area. This area is reserved for our customers, and there are available recording of the appointment. Also available in this area is a form for submitting a methodological question, which will be answered by our supporting staff. These are other features of the Launchbox. In this, through this dashboard, you could add additional tools such as Data Access Pack and the feature to manage concurrent SPSS statistics software, and user manuals in English mother tongue, of course. Okay, As operational tools, we have developed premium modules, and the youngest one is a Udon module that helps you in cutoff of a rock curve. And another premium module is P-score that makes strength the propensity score matching techniques in your solution. Some days ago, you have received a notice that our app Statistics for Data Analysis is ready to work in English too. And we are very glad of this project that we arrive at the end in time. And through the app, there are some tips and tricks, useful suggestion for using statistics for data analysis solution in a smarter and clever way. Via app in mobile, you could see recording of webinar too. Okay, and there are some information about our solution bundle. Of course, you could download our app Statistics for Data Analysis through App Stores or Google Play too. Okay, this is in a nutshell all our operational tools that we are trying to enrich every day with your suggestion, of course. Thanks to our knowledge and through the ongoing dialogue with our customers, a few years ago we proposed our own statistics for data analysis configuration, designed to directly address the analysis need of different fields, such as socioeconomic, environmental, and so on. We also have online training classes, and in recent years we have strengthened our course offering and would love to become your partner for training on SPSS as well. Okay, now we are arrived at the core of the appointment, and so Arianna, I will give you the floor. Okay.
Thank you, Cristina. I think you need to make me the presenter.
Yes, I'm doing this. If you have any question, please use questions and answer area, and we will try to answer at the end of the webinar. Thank you for your attention and have a good webinar. Thank you, Arianna.
Okay, so good afternoon, everyone. Today we are going to discuss criteria to choose a statistical test. We will try to make example on where to choose a method or another. And we will focus for today on a very simple bivariate analysis. So this is shortly, very briefly, the agenda for today. I will give you a very brief introduction. Thanks, Cristina, I have already covered the introduction to the environment of statistics for data analysis, so I will concentrate on the statistical part of the webinar, which concern the possible choice between parametric and non-parametric tests. So I will do a very short reminder about the main differences between the two methods, and we will use an example data set to make an example of testing an independent sample comparison or a pair design comparison. And as usual in our training event, the approach will be very practical and pragmatical, and so I will show you how to use the software to obtain the analysis and how to interpret the result. So coming to the brief introduction to the non-parametric procedure, for those of you who are not very familiar with this terminology, A parametric test is a test which assumes that the variable that is going to be tested follow a normal distribution. Particularly is the mean, the sample mean, which follow the normal distribution. On the other hand, a non-parametric test is a test that do not require such an assumption. So this is the reason why non-parametric tests are thought as more flexible. They are for sure less restrictive in their assumption. They therefore they can be used in small sample exercise when it's very difficult to for instance exclude some extreme observation which may be the cause of the bias affecting the sample mean. And so for small sample, very often people tend to use non-parametric test. And again, in any situation where different population, and here with population, I mean data population, so data that are distributed with different distribution shape can be compared with the non-parametric procedure. And the reason why this is possible is because a non-parametric procedure operates a transformation of the quantitative data into something similar to an ordinal variable, into the so-called ranks. But we will explain better this with an example later. We have advantages. I list the advantages. I need also to mention the disadvantages of following this procedure. When the procedure, when the distribution of the sample match the normality assumption, and people use instead non-parametric test instead of the parametric one. Simulation studies have demonstrated that with the same information, parametric tests are more statistically robust, so they are more reliable. And I will explain when, in which situation, to avoid using a parametric test could be a disadvantage. Okay, so the first type of comparison I wanted to discuss is the independent sample comparison, meaning that we are going to compare two different sample means, wanting to test the hypothesis that these two means do derive by the same data distribution. And the first test I will consider is the parametric t-test. That is the main pathway when people want to compare two sample means following the parametric approach. The corresponding non-parametric test is the so-called Mann-Whitney rank test. This is one of the many, because there are many non-parametric procedures which are available for testing the same t-test situation. But before explaining the difference between these two procedures, I want to show you the case study we are going to consider. So this data set contain pollutant concentration coming from two different monitoring stations. One monitoring station concern so-called background condition, meaning that in this station the general pollution of the area is recorded far from specific pollutant sources, while the second type of station providing data for this example is the roadside station, placed very close to a very crowded and with heavy traffic road infrastructure. So the main goal of our investigation will be to compare one pollutant. I will use ozone as an example. Ozone is a typical summer pollutant of urban smog, and we will try to compare the general, the central tendency of the ozone concentration in the two situation. But before doing that, the first thing that is important to assess is the distribution of the ozone. So my target variable is ozone concentration, and I will use to investigate the presence of extreme or simply the distribution of the parameter, the explore command. Explore command is specifically designed to study the univariate distribution of a variable, but it has also the possibility of including a factor variable, which is a variable which contains the information about how to group the data together. So for us, the indication of the type of monitoring station will be, you are not seeing the case study. Maybe you're right. I need to share also this. Thank you for this. I hope that now feels visible for everyone.
Yes, Arianna, we will see it.
Okay, sorry for that. So I will quickly show where the explore command is in the analyze menu of statistics. Is included within the descriptive statistics menu, and by selecting ozone, I will reset my previous option here. I can select the ozone parameter as dependent. In the explore terminology, the dependent variable is the variable quantitative on which I want to calculate the descriptive statistics and also to assess the distribution. This box here that is empty is a box available for grouping variables. And in statistics, the grouping variables, meaning the variables containing the information about how to split the data into different samples, they are called factor. Okay, so I will start with the univariate analysis of the ozone parameter. And I will also request, besides the default setting of this command, I will also request the histogram. I will avoid using the stem and leaf chart, which is very similar to the histogram, but aesthetically much less efficient, in my opinion. I just want to underline the fact that I'm not selecting the normality plot and test here, because to decide whether to use a parametric or non-parametric procedure, I do not need to run a normality test. So this is probably breaking news for some of you, but I will try to explain why I'm saying this. So I am running the command. So in a while, the results should be visible in the output environment of statistics. And you can see from the output here, I hope you can see it, I have more than 260, no more, I have 260 observation of this ozone concentration. My sample mean is 33.3. But if I compare these sample means with the median of the sample, I can see that there is a slight difference. The median is 31.4. I might, let's say, I might be undecided whether to consider important such a difference between mean and median, which are both central tendency indicator. I have another warning here. Since associated to the sample mean, I have also the confidence interval for the mean. I can see that the median fall very close to the lower bound of the confidence interval, but is outside of the confidence interval. This could be also the effect of some outlier. Besides the statistics, I am also looking at the distribution of the data itself using the histogram, and I can see here that there are some observations which appear to be in a way very separated from the core, the bulk of the other data. This information is even more evident when considering the box plot. The box plot show the variable distribution and highlight the presence of outlier using the interquartile range, which is the difference between the upper side of the box, that is the 75th percentile, minus the lower side being the 25th percentile. So this, the box height is the interquartile range, which is a non-parametric, we could say, measure of variability. Within the box, by definition of percentile, we have 50% of the data. So using the box plot approach, any observation which is higher or lower from the upper fence of the box, that is the 75th percentile, more than 3 times the height of the box, the interquartile range, in this chart is shown as a star. So the star are extreme outlier. It's very possible that the difference we were observing between the sample mean and the median, this black line at the center of the box is the median, the 50 percentile. And we can see, looking at the shape of the box with a whisker, which represent the minimum and maximum value considered not outlier, using the criteria of the interquartile range. So we might decide, especially if we have additional suspect that this measurement could be errors of the measurement or of the sensor that are employed to this purpose, and to quickly get rid of this outlier, I will use a specific add-on which we can find under the data menu. As you can see, there is a specific menu that is added to the basic statistics for data analysis menu, showing the customized add-on which are available for user convenience. So in my case, I will use this exclude outlier add-on. The selection of the add-on opens these windows, and I may put here my control variable, which is still ozone, my dependent, and I need also to to include here the exclusion criterion. And in my case, this n will be twice the standard deviation. So any value which is over 2 times the standard deviation will be clean and removed from my data set. I will also use the browse command to save this new clean file on my computer. So actually I am replacing the file I have already. I will execute the command. Again, if I go on the output, I can see that some analysis were done within the add-on procedure. Particularly, I have a very concentrate table of statistics. And also, if I open that file that has been created, I have the new file clean with no outlier. So if I run again the explore command, and this time I will do that by including also as factor list the station type. So I will put again ozone here. If I just leave everything as it is, I will obtain the exact copy of the previous analysis without the stars. Maybe it's worthwhile to see that. Will be very quick in any case. Okay, I go straight. I can see also from the histogram that the outlier are not there anymore. The box plot now is nice and clean with no stars, and so I have the possibility of investigating the distribution in the two groups. Sorry, I missed the explore. Here we go. So I'm running exactly the same analysis, but this time I am also including the factor variable. This variable explain which ozone concentration belongs to the background station and which are the other value which instead are taken from the roadside station. So by doing that, including the factor, explore command will produce separate report for the two type of station. Is a sort of stratified analysis, and I can see here, for instance, even looking at the mean and the confidence interval for mean. So after a very quick comparison, I can see that roadside apparently have a lower concentration of ozone, and even looking at the confidence interval lower and upper bounds, I can see that the two intervals are not overlapping at all. So already this information suggests that I will find a significant difference between the two mean. Just have a quick look on the two histogram and also on the two box plot. The box plots are very important because they show that the distribution of the value is very symmetrical, and it's a good news because the symmetry is the first condition which guarantees for the sample mean not being biased. So looking at these two box plot, I would have any reason for using a non-parametric procedure. So the first thing I will do is to run the independent sample t-test. Using again ozone as test variable, and I need here to use again the station is very useful for this to this purpose to use a variable that is numeric, possibly with value labels, indicating that the code 2 is associated with the background station and code 3 is instead roadside. And I am also requested here to define which are the groups and the level I want to compare. So my two groups are 2 and 3. So I will put these two numbers here, and I will simply run the procedure. And as you can see here, I have the shortcut to the main statistics associated to the sample means, which are the standard deviation and the standard error of the mean. So these two parameters, the mean and the standard error of the mean, are the two parameters that are used to draw the confidence interval. Let's have a look to the test results. Even though I selected the procedure of the independent t-test, which is, independent sample t-test, which is a test that compare two sample means, the software have generated an additional test. The test that compare the two standard deviation, or the two variants, if you want. The standard deviation and variance are linked because one is the squared of the other. But when using any parametric procedure, people have generally to pay attention to both the mean, which is the main goal of the comparison, but also to the other parameters, that is the variance. And in fact, as we can see here from the standard deviation, the roadside data apparently have a lower standard deviation than the background station. And if we look at the significance level of this Levene's test, which compare exactly the two group variances, we need to conclude that we are rejecting the null hypothesis. The null hypothesis is an hypothesis which contains always an equality condition. So our equality condition here is even written in the cell of the table, and it is the equality of the variances. I have obtained a significance level, a p-value. I mean, these are all synonymous for meaning the same thing. And since this significance is below 0.05, that is the 5% cutoff, we are allowed to conclude that the two variants are different. This conclusion has implication also on the interpretation of the t-test. In fact, we would need to read the results of the t-test at the second row in this table, which does not assume equal variances. And as you can see, in terms of formula, the two t evaluation are very similar, but the degree of freedom of the two statistics are very different. And this is because when the variance, the group variants are different, it is needed a higher quotient. And this higher quotient statistically is given by assuming a sort of smaller sample than the real sample. So in this case, we are losing something like 20 observation in our test. So to test the hypothesis of the equality of means, as you can see, we are still unequal here as condition. I need to decide whether I want to consider my test one-sided or two-sided. Generally, people use the two-sided statistics. So my p-value is also well below the 5%. And also here, I need to conclude that the two sample means are different. In the following part of the table, we have also the estimate of this mean difference between the two means, which is around 9.5 unit of concentration for the ozone. And we have also a confidence interval of the difference. So the minimum difference between roadside and background is 7 units, while the maximum difference could be even almost 12. So let me go back to the slides and let's discuss very briefly the corresponding non-parametric procedure. As I said, there are many non-parametric procedures that could be used, let's say, to test the similar situation of the T-students test. But the Mann-Whitney U-test is by far the most diffused. And so again, since the main meaning of the statistical analysis is the standardization of the conclusion in data analysis, if there is a test that is more popular, it is worthwhile to consider that. Considering this Mann-Whitney procedure, even though we said before that non-parametric procedure consider ranks instead of the real quantitative variable of the dependent, in this case, this test consider the statistics U, which is given by the so-called number of precedences. And I will explain in the following slide what it is meant for that. Very short data example here. I have group A and group B and some observation belonging to a quantitative variable. I may sort this variable from the minimum to the maximum. This is the ranking and the sorting is very typical of any non-parametric procedure. And here you can see the results of the sorting. So the minimum value of the data series is 82 and the maximum is 242. But in the second row of this small table, we have still the provenience of that number. So 82 was a number of group A. Now it comes the calculation of the U statistics that need to be done separately for the two groups. So I will start from group A and I will start saying, okay, how many number belonging to group B precede 82? 0. Then I will go to the following A group number, which is 92. And again, the question is, how many numbers belonging to the other group precede this 92? And it's 1. Okay, so here I have 1. Then I need to jump to the following A number, and I have another 1, and so forth, until I reach a global value of precedences, which is 11. I can do the same for the group B, obtaining another U value. And at this point, I will consider only the minimum of the two U I have obtained. At this point, as a sort of magic, there are some, let's say, parametric statistics, even in the Mann-Whitney test involved. Since if the two groups have more or less the same central tendency, being a non-parametric approach, our central tendency should be the two median, then the mean value of the U statistics should be something that can be calculated just considering the number of observation in the two groups. So N1 is the number of observation of group A, and N2 is the number of observation in group B. Similarly, I may also estimate a variability of these U statistics. And in the end, I may even obtain a standardized Z score for the U variable. The unexpected news here is that even if I am following a non-parametric procedure, I may still read the results of the test in terms of significance level by considering let's say a parametric statistics again, a Z-score. Let's see how it will work by doing that with statistics. And I will pick here the non-parametric test from the non-parametric menu that is available under the Analyze larger menu. The interesting characteristics of this menu is that I don't need to choose the test here. I simply need to choose the type of comparison I'm interested in. So I will select the independent sample. I will select the dependent variable, which is still ozone. And as you can see here, I still need to define the groups using the type of station I have in my data set. I could simply run the command here, but I just want to show that the general setting of this command is that the software will automatically choose the test based on the data. And with no surprise, the first test that will be selected is the Mann-Whitney U test we just discussed. If I want to run a different test, I can always go in this setting menu and decide which test I want instead. If I leave the default, I will obtain the Mann-Whitney test. Okay. Still running. There it is. Okay, so the non-parametric procedure has many table and chart to consider, but the very first table already contains all the information we are interested in. It states which is the null hypothesis, which is that the ozone is the sample mean. Here is talking about distribution as a whole, because some of the tests do not test only the central tendency, but the whole distribution. So this is a generic null hypothesis. But the main concept is that the quality condition is the null hypothesis. So in our case, the two median of the background and roadside station are the same. And the test chosen is Mann-Whitney U test, and the significance level, exactly as in the case of the t-test, is below 0.05. And the decision is also given here, reject the null hypothesis, meaning that there is a median which is higher than the median of the other group. In this table, we have the complete set of statistics. And again, here we can see this minus 6.7 is exactly the value of the Z-score that is obtained using this formula here, and the estimate of the mean of the U statistics and the variability of the U statistics. So using this Z-score, which has a known normal distribution, the software is able to estimate the asymptotic significance level, which, as you can recall, is very similar to the one we have already obtained using the t-test. In this chart, the software is also comparing the distribution of the two station data, and it's very evident here that the background has a right tail of higher value, which are not even there in the roadside distribution. So the difference in terms of central tendency, it is quite evident from this chart. There are also other additional charts, but since we have running late with time, and I want also to discuss briefly the other type of comparison, the pair design, I'm not paying attention to these further details. The interesting part about using ozone as a pollutant is that since ozone has let's say, a clear relationship with solar irradiation, ozone is a pollutant which show daily pattern, which are very similar and follow the sun irradiation. So in this case, it could be interesting. I mean, if we look how the data set is organized here, we have one single column of ozone value and the variable containing the information about the type of station those measurements belong. I may try, since as you can see, I have the date here referring to the measurements. This is only, I think, a monthly time series, but in theory, this should be also done on an hourly basis, a daily basis. But even at the monthly basis, it might be reasonable to compare the value of the two stations using a pair design. What does it mean, a pair design? It will be easier to understand looking at the dataset restructure for this purpose. So if I restructure the dataset like this, I have one column considering only the ozone measurement for the roadside station, and this value is directly compared with the ozone measurement of the background station corresponding for the corresponding month and year. So in this case, I have paired the information of the two groups. And if I can do that, let's say the first assessment I should do when doing that is the presence of a correlation between the value of ozone measured for the same month in the two stations. If this correlation exists, then it is a very reasonable choice to use the pair design. So again, we have very little time, so I will not spend too much on this. I just want to show you the difference also in the setting of the test, which is needed if we follow the parametric approach. So if we follow the parametric approach, we are still in the case of comparing means, even though, as I will explain, the mean I will be comparing here is not the two separate sample mean belonging to the background or the roadside, but I will compare the difference between the value. Here in this part of the table, I have also already calculated the difference between the value of ozone measured at the two type of station, and I will compare the mean of this difference towards 0. This is because I want to test the hypothesis of these two being equal or not. So to do that, I will select under the compare means menu, again, parametric. So compare means is always parametric because mean itself is a parametric statistics. So as you can see, the pair sample t-test require data in a paired format. So without this table restructure, I couldn't run this command. I couldn't include the two variables as requested. So I will select both the two variables I'm interested in, and I will simply run the test. So again, here I have the table with the statistics. These are exactly the same we had before. The new there is a new table included in this output that is the correlation between the two, and we can see that the correlation is very high. This is a correlation coefficient of 0.97, so they are almost the same. And we have also a test here associated to this coefficient of correlation being equal to 0. So again, we strongly reject the hypothesis that this correlation coefficient is equal to 0, meaning that the two values are really correlated. And this is the pair sample test. So I have this mean here, that is the mean of the differences between the ozone measured at the roadside minus ozone at the background station. And finally, according to this significance term, I can also reject the hypothesis that this mean is equal to 0. So since I have also a sign here, I can see that for every month, the ozone concentration at the roadside is about 10 units of concentration lower than the background. Okay. I will not discuss the effect size because we have really no time for that. Just very quickly about the corresponding non-parametric procedure for the pair design. We have the Wilcoxon rank test, which is again the non-parametric test which is used by most of the researcher as corresponding for the pair t-test. And also the calculation of the statistics is similar because the pair design, this is really ozone again. Here the pair design is by hour. So for every hour of the day, the ozone concentration are compared day by day. And a difference is computed between these two specific days. In our case, this was the same month. And again, the difference was between two different measurement points. As you can see, the differences can be negative or positive. And at this point, we have the transformation into rank, but keeping the sign. So the differences are sorted from the minimum to the maximum, and the rank is assigned based on the absolute value of these differences. Finally, the rank are considered separately, the negative and the positive. And again, there is a statistics here that is the Wilcoxon capital T, which sum the rank having the same sign. So if the two groups are more or less the same, this T will tend to an average value of T, which can be estimated just looking at the number of observations I have in my data set. And exactly as we saw before, I can also estimate the variability of the T statistic simply using an empirical formula having only n number of observations as the only variable that need to be considered. And so I may standardize the T value I have obtained on my dataset into a Z-score and read the significance level of the test directly using this Z-score. We can do that exactly as we did before, using the non-parametric menu. I need to select this time the related sample type of test. And exactly as before, I need to select the two different ozone measurement, roadside and background, and run the test. As you can see, exactly likewise, the output we had before, the first table summarizes either the null hypothesis, the type of test, the significance level of the test, and also gives the decision to take, which is also to reject the null hypothesis. And in the following table, we have the complete box of the statistics, the T statistic that was used, that is normally the lower T of the two that are considered. And this chart is even, I mean, is really evidence because it shows only positive differences between the two. There is never the case of a negative difference. So we are also pretty sure about that, we can conclude that the median of the differences between the two stations is not equals to 0 because the roadside has a much lower concentration than the background. Okay, I think I have more or less covered all the topic which were scheduled for this webinar. And I thank you everyone for the attention, and I don't know how we will manage with the question and answer, so I will ask Cristina for instruction.
Yes, Arianna. Thank you very much, Arianna. We have received some questions and some messages of congratulations. And so first of all, the congratulations for the interesting of the webinar.
Thank you.
About the question, the first one is quite simple for you. How many records can be processed with SPSS?
Well, it's not a simple question. I really don't know. I can testify that I used a data set with some millions of records. I don't know if there is a limit actually.
No, I know it, and there are no limits about record. You can insert in statistics for data analysis. I'm prepared.
Very well.
And this another question, which is the difference between parametric and non-parametric tests? You have talked about the very beginning of the webinar.
Yes, as I try to explain, the main difference is the assumption about the test statistics, the sample mean. So for a parametric procedure, we are assuming the normal distribution of the sample mean. And we are using this distribution to extract the connected statistic. The t-test is a direct, let's say, a statistic that directly derives from this normal curve of the sample means. For the non-parametric procedure, we don't have such an assumption. So as I was trying to explain, the main question this procedure are able to answer is whether the two central tendency statistics, which are sort of two medians, mean rank and medians are very similar to each other, if they are the same or not. So this type of test allow to compare distribution that can be very different, but also the level of information connected is lower. At the end of a parametric test, for instance, we knew also about the variability, so the other component of the distribution. We are not able to have this information if we simply run a non-parametric procedure. So the main idea is that I should use non-parametric procedure only in those situations where the sample mean is biased because it's very far from the median. So in those conditions, we cannot rely sample means because sample means are very sensitive to the presence of outlier, but also to the lack of symmetry in the data distribution. So there are situations where the sample mean cannot be corrected, as I did very quickly at the beginning of this webinar. And in this situation, non-parametric procedure are valid alternative.
Okay, thank you, Arianna. Last question is this one. Why did we exclude the outliers And why did we use the standard deviation equal to 2 as the exclusion criterion?
Okay, this is also another very good question. I mean, the exclusion of outlier is always a very delicate procedure. In some situation where I know for sure that those very large values are mistakes or they derive from very different conditions that I do not want to be mixed to the other situation I'm going to investigate. Excluding them it's a good decision. It's true that also in this case, even keeping the outlier, the differences between the two sample means were too striking and too evident that we should have even kept the outlier, having still a robust comparison using the t-test. Why I use the two standard deviation, this is a sort of rule of thumb. If I want to identify very quickly a potential outlier, I can use this two standard deviation metric to identify them. Then it's never so automatic as I did. Since if I identify some values that are extremes or outlier, the first thing I need to do is to assess whether they are still valid or not. So let's say I show the possibility of quickly identify these values and eliminated them. And sometimes this is an healthy procedure because there are some error even in automatic measurement sensor. So I could use standard deviation or other criteria to identify that. I don't know if this answer to the question. I hope so.
Okay, Arianna, sorry, I am reading because we received
Many
some
questions.
other questions yes, now. And I read the last one. Is it recommended to exclude data that have deviation?
Again, another question about outlier. It depends. I mean, if my goal is to have a robust estimate of the central tendency, I would say yes, because keeping those data will certainly affect the reliability of the sample mean as central tendency. That doesn't mean that I will ignore at all those values, but I will eliminate their bias when I need to define a sample mean and more importantly, a confidence interval for the mean. Probably we should have a webinar all dedicated to the management of outlier, which is a very delicate topic by itself, I mean.
Of course. Thank you, Arianna. To the other question, we will answer in the next days, so don't worry.
Okay.
If you want to give me the role of relator, so I make only the conclusion.
Let me see if I know how to do it. I hope so.
If you click on my name.
Are you sure you are not? Because I have...
I am
it's
not
myself that I have to receive the role. So let me see if I can...
because I haven't okay, now it's
okay.
Okay, thank you very much, Arianna.
I didn't do anything, but okay.
It's a miracle. Okay, so Thank you everyone for your attention. I would like only to give you some information about our online training offer, because with Arianna and some other staff of our training team, we have defined our English mother tongue courses, and the courses are the way to go in deep the theme that Arianna today have only talked in a very fast way. We have set in our agenda the first online training is intro online, starting from the end of November, from 28th November to the 2nd of December. We hope that the time we define is right for you too. And this is the very first appointment for the new user of the solution statistics for data analysis. During this appointment of perhaps 13 hours, you will understand how to construct and manage a database of cases. Okay, these are the techniques that our teacher will present during the appointment, and you could find all this information on our website in the area reserved to the training. These are the webinars that we have set for the next month, and all your suggestions will be useful to work on new topics. And we are thinking about like a way to make you understand how is easy to use statistics for data analysis solution in comparison of Excel or our software, because we received from some customers this feedback. About value-added services, yes, as already said in the beginning, we reserved for our customers these services because we would like to stay with you in all your analysis activities. So we are with you for technical assistance in managing changing of codes or with webinar or with the customers area, and all the material that we share there for you. Sorry, I made a mistake. Okay, you are going to receive a survey in order to give us your feedback about the appointment of today. Please write free which is your feedback, and for us it's very important to work on it. These are my dates, and SPS staff, marketing or training is at your disposal with me for any question about information for the solution statistics for data analysis or training too. We are working to reach you worldwide, and we are very pleased that today you are here with us. Thank you very much for your attention, and if you would like information about intro, we are here. If you would like to receive the slides that Arianna used today, follow our page in LinkedIn, SPS page, and you will find the slides there. And the recording of the appointment will be available via mobile or in the customers area too. Have a nice evening. Thank you very much. Bye-bye.